The height function is a quadratic function. So from the previous video, we looked at the height of a golf ball, and that is a quadratic function in standard form. The standard form of any quadratic function is written f of x equals ax squared plus bx plus c. The graph of any quadratic function is called a parabola. So we have some parabolas here drawn below. When a, that leading coefficient in front of the x squared, this a here, is bigger than 0, we have a parabola that opens up. So this one here is a positive a, it opens up, it looks like a u. When a is negative, when it's less than 0, like this one here, it opens down. It looks like an upside down U. When the graph of a parabola opens up, we're going to get a minimum value every time. We have a smallest y value. We're going to have a minimum value located at the vertex of the graph. This minimum value is called the vertex. When the graph of the parabola opens down, the function is going to have a maximum. We have a highest point of the graph is a maximum, and that is also located at the vertex. So the vertex could be the max or the min, depending upon which way the parabola opens. So a positive a has a minimum. A negative a has a maximum. So looking back at our golf ball function from the video before this, how might the golf ball height function be used to determine if the parabola opens up or opens down? Well, you could either look at the graph from the page before. We already graphed this on the page before. Or we can look at this negative a. A is negative 16, which is less than 0, which means we are going to have an upside down parabola. It's going to start on the ground, reach a max, and then go back to the ground. The vertex of any quadratic function may be found using this vertex formula. So we kind of guessed where we thought the max height would be based on our chart, but we could have found the exact x value for a maximum height by plugging into the formula where x equals negative b divided by 2a. And then you take that value for negative b over 2a, and you plug it into the function that will give you the y value of the vertex. So we're going to use that vertex formula to find the vertex of the golf ball function and state that maximum height exactly with the exact time that it happens. So we're going to use the vertex formula to start. So the vertex is going to be negative b over 2a. So in our function here, we have ax squared plus bx plus c as our standard form. So in our function, a is negative 16 and b is positive 60. There's no value for c. C is 0 for this one. So plugging into this formula, I'm going to have negative 60 over 2 times negative 16. So I would get negative 60 divided by negative 32. So the x value, or in this case, we would label it as a t value, would be 1.875. So t would be 1.875, or the x value of the point, and we're going to find the y value of the point by plugging into the original function. So the y value, in this case the h value, would be 1.875 being plugged in for my time. Negative 16 times 1.875 squared plus 60 times 1.875. So going into that original function and replacing both of those t's in here. So when I do that in my calculator, I'm getting a max height. Well, we did this problem in the video before. We said our max height was about 56 and it was around 2 seconds. So our exact t value is actually 1.875, and we can see what the y value is there. It's actually 56.25. So my vertex is 1.875 comma 56.25, which means I know my max height and the time to reach the max height. So first of all, we found the time was 1.875 seconds for my t, and the height is 56.25. That was the output in feet. So we've just talked about the standard form for a parabola and how we can apply it to our word problem using that standard form to find the vertex, which is always negative b over 2a, and then knowing the value of a tells us whether the parabola opens up or down. So that vertex, since it opens down, is a maximum. If it opened up, we would have found the vertex, which would be a minimum.